Welcome to your IELTS listening practice from Spinta.org. This is a mini-test designed to help you practice a specific section of the exam and improve your confidence. The recording will be played one time only, just like in the official test. Let's begin.
Good day, everyone. Today, we will be discussing a fascinating topic in evolutionary biology known as convergent evolution. This concept is incredibly significant, as it addresses the phenomenon of similar solutions in unrelated species. Through today's lecture, we will explore various examples of convergent evolution, thereby illuminating how distinct species can arrive at similar adaptations through different evolutionary paths. First, let us define convergent evolution. Convergent evolution occurs when species from different evolutionary backgrounds develop similar traits or adaptations. This typically happens because they occupy similar ecological niches, or face comparable selection pressures. For instance, when considering the wing structure of birds and bats, it's profound to realize that both groups have evolved the ability to fly, but they have arrived at this trait through distinct evolutionary histories. Birds are descendants of theropod dinosaurs, whereas bats belong to the order of mammals. Now, if we reflect on the similarities in body shapes and adaptations among various species, it becomes evident that the ecological concept of convergent evolution can lead to certain predictable outcomes. For example, streamlined bodies designed for efficient swimming can be seen in diverse aquatic organisms, like the dolphin, a mammal, and the shark, a fish. Despite the fact that these species belong to completely different classes, their adaptations to a similar aquatic environment lead to comparable physical attributes. We can expand our discussion by examining the fascinating world of the carnation family. Within this family, we observe strikingly similar plant structures that have emerged independently in unrelated species. This convergent evolution is especially observable in flowering plants, where certain structures might facilitate pollinator attraction, showing similar morphological traits due to comparable ecological demands. Next, let's delve into the realm of marsupials and placental mammals. Predominantly, in isolated environments, marsupials in Australia have evolved traits that resemble those of placental mammals in other regions, despite their differing origins. A classic example involves the Tasmanian wolf, which closely resembles the placental mammal, the wolf, fulfilling a similar ecological role, despite their genetic divergences. Another outstanding example of convergent evolution can be observed in the context of visual and sensory adaptations. Creatures such as mantis shrimp, and certain species of human-made sensors, exhibit a form of advanced electromagnetic senses. Both have adapted to interact effectively with their environments, showing how different organisms can solve sensory challenges in quite similar ways. Furthermore, if we take a closer look at the adaptations regarding predatory strategies, we notice that species such as falcons and predatory fish evolve adaptations that aid them in hunting. These adaptations can include a remarkable similarity in body structure and speed, which equips them to be efficient predators, despite the fact that they belong to distinctly different taxonomic groups. I'd like to highlight the role of blood clotting mechanisms in different vertebrates as another significant aspect of convergent evolution. Research indicates that various vertebrate species have evolved remarkably similar blood clotting systems, which are crucial for survival when faced with injuries or wounds. This case illustrates how selective pressures can drive species towards analogous solutions, despite their differing evolutionary backgrounds. In summary, the study of convergent evolution enriches our understanding of evolutionary biology by demonstrating that similar traits often arise in unrelated species facing analogous challenges. The array of examples we've examined today illustrates a key concept. Traits can converge independently through adaptation to similar ecological roles, yielding similar solutions in an astonishing range of organisms. In conclusion, understanding convergent evolution not only provides clarity on how organisms adapt, but also sheds light on the intricate web of life, connecting various species across time and space. The examples of wing structures, streamlined bodies, and visual adaptations, among many others we discussed, reflect evolution's ability to craft solutions irrespective of the lineage. Thank you for your attention, and I hope this lecture has provided you with a deep insight into the remarkable occurrences of convergent evolution.
You have now completed the practice test. When you are ready for a full exam experience, visit us at Spinta.org. There you will find complete mock tests for all 4 skills: listening, reading, writing, and speaking. Our platform provides instant AI feedback for your speaking and writing tasks, along with an accurate prediction of your band score. Take control of your preparation at Spinta.org.